probability of success. R is this number here. And then Q, probability of failure, and then N minus R. Things to remember is that P and Q, when added up, give you 100%. And that these two guys, these exponents, when added up, always give me N. So it kind of works out in our favor. Okay, so we are going to do a problem. I have a pentagonal spinner that is regular. Pentagonal meaning how many sides? 5. Regular means they all should be the same size. Good luck to me. But you guys got the idea. We're going to call it the regular. We're going to call them they look like the same. Yeah. What the SAT used to say, not drawn to scale or something like that. I don't know. The image that I drew is not necessarily the image that you should be seeing. So anyway, we have, I'm going to say we have A, B, A, C, and D. A, B, A, C, D. We are going to take a regular pentagonal spinner. We're going to spin it 10 times. Okay. I want to know the probability that we get exactly 3 A's. So if I'm writing this out, I'm looking for the probability that we get exactly 3 A's. I want to know what's the probability that we get exactly 3 A's. Okay, the formula says, maybe I don't know, do they write this up there on your paper? Do they write probability of X equals R?
It's P and then like a lower R.
A little r,
Yeah.
probability of R, okay. So they don't give you that. Okay, we won't do that then. Like that, probability of little r, okay. So we're gonna find the probability that X equals exactly 3 A's when I do my spinner, okay? So we're gonna break this down. How many trials are we doing in this thing?
10.
We're doing 10. We're spinning this guy 10 times, okay? What are we trying to get? We're trying to get how many A's? 3. We're trying to get 3 A's. Mm-hmm. What is the probability of success in this scenario?
2 out of 5.
2 out of 5. How many A's are there? 2. How many total guys in there? 5. So it's 2 out of the 5. So my probability of success is 2/5. What's my probability of failure? 3 out of 5, right? Because what are they supposed to add up to? 1 whole, yes, very good. What's my exponential power for my probability of success in this case?
3.
It is indeed 3, because it's the R. And then what's my probability, my exponential power for my failure?
7.
It is 7. Things to note, 7 plus 3 gave me 10. Check, I've done that right. Always add your exponential power, see if it gives you that total number of trials. Now you just have to use your calculator. You're going to plug in 10 choose 3 times 2/5 to the 3rd times 3/5 to the 7th. The exponential powers always add up to the total number of trials. That's a good way to think about it. They use N minus R, which is 10 minus 3 in this case, but I always just say, whatever I get here, I'm going to add to there to get this. Kind of keeps me in mind.
Where'd you get the 2/5 and 3/5?
Okay, that's good. So probability of success, in this case, our success is getting an A. So I have 2 A's out of 1, 2, 3, 4, 5. So 2/5. 2/5 probability of getting an A.
And 3/5's not.
Correct.
Okay.
That's my failure.
Right here. Oh, that's
Yeah.
I got that.
Oh, what'd you get?
21.4.
Point. Oh, you gave me as a yeah. So
21.5%.
so 21.5 or 0.215. Very good. Very good. Excellent. I gotta write your mom back.
21.5.
Yesterday I was really busy, but she wrote to me, I think. 21.5% chance of getting 3 A's. Are we cool? Easy enough? The hard part is sticking it in that calculator and getting those right. Okay, now we're going to do another problem. I'm going to give you an actual problem. X is a binomial, and then I have 8 and 0.7. What did I just give you in that problem? What is 8? Number of trials. Whatever I'm doing. I don't know. I'm spinning, I'm tossing, I'm throwing. Okay, number of trials. And then what is 0.7 in this case? Success. The probability of my having success, right? Okay? Before I even begin, what's the probability of me having failure? 0.3. Okay, everybody good with that? Sweet. So I want to know, what is the probability that X is greater than 6? So what are the numbers that make up the number of trials? How many, like specify my numbers that make up the trial? They are number 1, 2, 3, trial 1, trial 2, 3, all the way up to 8. 1, 2, 3, 4, 5, 6, 7, 8, right? Okay? I am looking for the probability that when X is greater than 6. So what are the two things that make up the numbers of X is greater than 6? 7 and 8. So I'm literally trying to find the probability of 7 plus the probability of 8. Does that make sense? So I'm going to find the probability of 7. Let's remind ourselves how we fix that up. How many total trials are there? N is 8. What am I looking for this first guy? 7. What is my probability of success? 0.7. And then 0.7. And then what's my probability of failure? 0.3. What's my exponential power for the 0.7 success? 7. It's this guy here. And then what's my exponential power for the other guy?
3.
What do they have to add up to?
Oh, 1.
I have to add up to 8, so it's a 1, right? Okay. Now, we have to do the next guy. What is the next one going to be? It's my total number of trials is 8, and I'm looking for the probability of what to happen? 8. Okay? My probability of success is blank. 0.7. What's my exponential power for that success? 8, indeed. What is my failure? 0.3. And then what's my exponential power? 0 is correct. You're going to crunch the numbers for this guy plus the numbers for that guy. It's the probability of getting 7 or the probability of getting 8, basically. So go ahead and put that together. That's what the book has. Anybody have trouble with that one? Or are we cool? Yes.
I just have a question. So in like the equation, what is the 0.7? Like, is that just success?
That is the probability of success.
Okay.
And then, because here it's N is my number of trials and P is the probability of success.
Okay. So,
Whatever we're looking for success.
Oh, so it would be the same for all of the numbers. Like if you did the probability you would get 5 or lower, and you did like 6, it would still be 0.7 for the
Yes.
Okay.
Yeah, every time. Yeah, very good. Very, very good. I got a question for you. What about, that was a good one. So what about if I took the same stuff here, and I want to do the probability that X is less than 6. What am I looking to do then? I'm looking to do what? 1, 2, 3, 4, 5. It sounds like fun. Yeah.
Oh, no.
No, go ahead.
I thought you were gonna ask how you would get the less than.
Oh, well.
Wait, couldn't you just drag?
Well, this was greater than 6 only. I think that's where y'all were both going. This is only 7 and 8. What are the numbers that make up less than 6? 1, 2, 3, 4, and 5. That's a lot though, yes? Oh, you were just stretching? I'm cool. I am too. So here's the deal. 1, 2, 3, 4, 5. It's not that many. But what can I do instead?
If you like find, I'm trying to think, like find the probability that it's 6, and then add that first one and subtract that from 1, so you have the other side.
Yes. So without like adding the one that we haven't done, we could do this. We could do the probability of less than 6, right? So we could do the probability of 6, 7, and 8. And then do what to that answer? And minus it. Because remember, all of it makes up. But what she said is, look, we've already done 7 and 8. So just do 6, add it to that answer, subtract it from 1, and you're good to go. Exactly right. Okay, are we cool? So instead of working harder, work smarter, right? So figure out, look, I know that's 5 and that's only 3, I'm going with the 3 instead. Cool? So go ahead and find the probability of 6, add the 0.255 to it, and then do 1 minus that answer.